Hello my dear friends. Today in this small video lecture I discuss some numerical analysis of forming operation. At first we want to know material behavior in metal forming. Okay. So sigma equal to K epsilon to the power n. What is that? K equal to strength coefficient. This is basically MPa megapascal. Sigma, all of you know the shear stress, and epsilon is shear strain. N is the exponent. Now I discuss flow stress. The flow stress, that is YF equal to K epsilon to the power n. Now stress and strain curve indicating location of average flow stress of YF and relation to yield strength Y and final flow stress YF. Average flow stress, that's mean mean flow stress, is the equation is Y bar sub F equal to K e to the power epsilon n by 1 plus n. Strain rate sensitivity, epsilon dot equal to V by H. What is H? Instantaneous height of the workpiece being deformed. Okay. If height, deformation speed, and V is a deformation speed, V is constant during whole operation. Strain rate will change with the help of H. Strain rate sensitivity. Using this plot approximate the straight line log graph, YF equal to C to the power M. C is the strain constant and M is the strain rate sensitivity component. Here, when you use cold working, when you use warm working, and when you use hot working, some temperature range, strain rate sensitivity exponent and coefficient is given. YF equal to A epsilon to the power n, epsilon to the power m. A is the strength coefficient combining effect of previous K and C values. Flat rolling and its analysis. Flat rolling, if we see the picture in this is the picture. Actually diameter is reduced. Okay, so that's why so many stresses is required. So what is the D? T0 minus TF. D means draft, T0 means starting thickness, and TF means final thickness. So draft is sometimes expressed as a fraction of stock thickness called reduction. So what is our D by T0? This is, in addition, thickness reduction, rolling usually increase work width also. If we apply high pressure, length will be decreased, obviously width will be increased. So this is called spreading. So this corresponds to equal to T0, W0, L0 equal to TF, WF, LF. That means TO actually, WO actually, and LO, that's mean initially. Okay, before applying stress, and TF, WF, LF actually after applying stress. Okay, so V0, VF actually entering and exit velocity of the work are there. Then slip S equal to VF minus VR by VR. S is the forward slip, VF is the final velocity, and V0 is the before velocity. So true strain experienced by the work in rolling is based on before and after stock thickness equation epsilon equal to ln T0 by TF. YF equal to I discussed earlier. So what is the D max? Equal to M square R. Now a coefficient of friction sufficient to perform rolling, roll phase F required to maintain separation, F equal to W0 to L P D capital F is a rolling force. That means our target is how much force is required. How we find out that? So F equal to Y bar F WL. Y bar is average flow stress. And what is L? Under root of R T0 minus TF. Before thickness and after thickness. This is the schematic view of rolling application when if you see that this is T0, this is TF, T0 is the initial diameter, TF is the after applying pressure the diameter will come in this way, T 0.5 FL, angular velocity 2 pi n, n is the rotational speed of the roll, that's what power equal to 2 pi n T. So what is the P? 2 pi n FL. Very simple formula. Now one problem is given in this way. A 300 mm wide strip, 25 mm thickness is fed through a rolling mill with two powered roller, each of radius equal to 250 mm. The work thickness is to be reduced to 22 mm in one pass at a roll speed of 50 revolves per minute. The work material has flow curve defined by K equal to 275 MPa and N equal to 0.15 and coefficient of friction between the roll and the work is assumed to be 0.12. Determine if the friction is sufficient to permit the rolling operation to be accomplished. So calculate the rolling force, torque and horsepower. Very important problem. It's maybe come in your exam and maybe so many competitive exam, etc. So I discuss one by one. The draft attempt in this roll operation is basically 25 minus 22 3 mm. So what is the Dmax? The formula, all of you know that 0.12 square into 250. The value is there. Find out the L, YF, all of you know the formula. Find the first epsilon, T0 by TF, and you find out YF. Then what is the F? Then T, F means rolling force, torque required, the formula. If you forget that, I back my presentation. This 0.5 FL, P equal to 2 pi n FL. So, if F and T in your hand, so what is the power? The formula is this. So, we convert this in horsepower.